Hello everyone, my name is Putu Krsna, and today we are going to discuss about Archimedes law and experiment that I have done. My student number is 2405531025. I'm majoring in mechanical engineering and I'm from Udayana University. Now, first we're going to talk about the background and what is Archimedes law. Now, Archimedes' law states that an object that is entirely submerged will have a force that brings it up. It is found by Archimedes in 287 to 212 BC, a scientist from ancient Greek. Now, for the more detailed one, it is when a force is submerged almost or entirely to a fluid, which is like water or something like that, it will have a force that will bring it up. And that is going to be the same as the mass of the fluid that has been displaced by the object. Now, second one is buoyant concept. Now, the buoyant force concept is when an object is submerged in a fluid, the fluid will give pressure to all of its surfaces. Now, the fluid pressure will add as deep as the object go. Now, third one is the difference. The difference of pressure is between of surfaces from the underside of the surface and the top side of the surface. The underside of the surface will have more pressure, which going to be the differences of the pressure that will be called buoyant force, or Fa. Now, Archimedes' law equation, there are two in our experiment, which is P equals rho times G times H. P is fluid pressure, rho is type of fluid mass, G is our gravitational force, and H is the depth of the object is. Fa is the Archimedes force. Fa equals P rho F times G times Vf. Now, Archimedes force can be acquired by that equation, which is rho F, which is type of fluid mass, kilogram per meter cubic. G is gravitational force, or in meter per s squared. Vf is the volume of displaced water, which is in meter cubic. Now, this is what we need to use our experiment. First is a dynamometer that we are going to use for measuring the weight of our object. Then we have a glass full of water. Secondly is a glass for spoiled water. Thirdly is bigger glass, or a glass that has measurement for milliliters. Then weights, so we can have variety of weights and that we can use for dynamometer, and a digital scale, where we are going to use it to measure the weights of the spilled water or the glass full of water. Now, this is going to be the Archimedes law procedures. First, we are going to measure the weight in the air using a dynamometer. Now, we have some variation. That means we have four weights. We're going to use 4 weights, 4 different weights, and we are going to measure it in the air using a dynamometer. A dynamometer is in Newton. Now, when we found the weight in Newton in the air, then we're going to measure the weight in water. We're going to use the same 4 different weights to measure the weight with the dynamometer, seeing it as in Newton. Then we'll calculate the Archimedes force from differences of weight. Now, how do we calculate Archimedes force from differences of weight using Archimedes law? Now, that is using the equation of rho Fa equals rho F times G times Vf. Now, Vf is in meter cubics. How do we get it? Meter cubics, we are going to use it from milliliter. See how the we are going to convert from the milliliter to meter cubic. Then we're going to just time it, meter cubics time rho time g. Now, after we calculate Archimedes force from differences of weight, we submerge the object in glass full of water and see how much of it is spilled. Then we are going to measure the spilled water in a bigger glass, like I said before, measuring it with milliliter, and then we're going to measure the mass of the water that has been moved using a digital scale. There is going to show us how much does it weigh. Now, after that, we are going to compare the Archimedes force with the mass of the water that has been moved or displaced. Now, Archimedes law table. Now, as I said before, the equation that we are going to use here is Fa equals rho F times G times Vf. As a reminder, rho F is the type mass fluid, the G is gravitational force, and Vf is the volume of the water that has been displaced. Now, number one of our experiments, the weight in the air in Newton is 0.5 Newton. The weight in the water is 0.2 Newton. The Archimedes force and the spilled water volume in milliliter is 7 milliliter. The spilled water weight is 0.06 Newton. Now, how do we get the spilled water volume? Is by measuring it in the glass beaker, where we can see in its measurement. Now, with Archimedes force, we are going to use water. Water, the mass type fluid of water is 1,000 kilograms per meter cubic. That's why we are going to use it from the first one is 7 milliliter, turn it into meter cubic, which is 7 times 10 minus 6 times 9.81 times 1,000 kilograms per meter cube. The result is 68.67 times 10 minus 3. The second one, we're going to use 70 milliliter. That is going to be converted to meter cubic, which is 17 times 10 minus 6. The result is 166.67 times 10 minus 3. The third one is 18 milliliter, with the result of 176.58 times 10 minus 3. The fourth one, and the last one is 156.96 times 10 minus 3. Now, summary. The buoyant force that we exert on an object is proportional of the volume on water that is displaced, and the weight of the object in the air is bigger in the object in the air. As you can see in this table, the spilled water, the weight in the water and weight in the air. The weight in the water is smaller than weight in the air. As you can see in the example of number 1, 0.2 newtons in water, while in the air, they are 0.5 newtons. That's it, everyone. Thank you for watching. I hope I can see you again.